Hello guys, welcome to our channel Rome Basic. So in this video we'll learn about the domain range of an inverse function. So assuming we have functions f of x and its inverse, so f of x equals to 3x plus 1 and its inverse, of f of x equals to x minus 1 over 3. So in this illustration, we will see the concept behind the domain and range of the function and its inverse. Okay, so let us solve for the domain of f of x. So our f of x equals to, again, 3x plus 1. So in solving your domain, we are just checking the restrictions of your denominator. So as you can see, we don't have a denominator, but we'll say that there is a denominator and the denominator will be 1. Or, you can say that the domain of this function are real numbers. So there is no restriction. Okay? Or we can write it using your set builder notation. X is an element, X such that X is an element of real number. Okay? Okay, by your set builder notation, so this one, if you have to write it using your interval notation, so we have and negative infinity. So from negative infinity to positive infinity. Okay? Okay, so how about the range of your f of x? So solving the range, let us first solve your function in terms of y, or we can say that f of x equals to 3x plus 1. We have y is equals to 3x plus 1. Then isolate x on the other side, so we have 3x, then we have y minus 1. Okay? And transfer plus 1, we have minus 1. Then divide both sides by 3. So we have x equals to y minus 1 over 3. So the denominator is a whole number. There is no variable there. So we can say that there is no restriction on your denominator. Again, there is no restriction on the denominator where this value becomes 0 or your rational function will become undefined. So we can say that the range are also all real numbers. Okay? Or in set builder notation, we can say that y such that y is an element of real number. And by interval notation, that is from negative infinity to positive infinity, or all real numbers. Okay, so I will do this for you to identify the difference between the domain and range of a function and its inverse. Okay, so let us go to the inverse of your function f and identify its domain. Okay, to make it simple, as we have discussed on the other video, the range of the function and the domain of its inverse are equal. Okay? So this range will become the domain of f of x, or the inverse of f of x. Okay? Without solving it. And its range the range of your f of x, or sorry, the domain of your f of x will become the range of your inverse. Okay, so our first example is very easy. Okay, so let's go to another example. Example, we have h of x equals to 2x plus 1 over 3x minus 4, and its inverse is 4x plus 1 over 3x minus 2. Okay, so let us first identify the domain and range of your h of x. So identifying the domain, we have to solve for the denominator. So solving the denominator, so we have 3x minus 4. Equate it to 0. Then solve for x. So minus 4 will be transferred. It will become positive 4. Using your addition property of equality, adding plus 4 and adding plus 4. So we have 3x on the other side. Divide both sides by 3. So dividing both sides by 3, we will get x is equal to 4 over 3. Right? So our domain is x is not equal to 4 over 3. Or using your set builder notation, x is an element of real number such that x is not equal to 4 over 3. Using your interval notation, we have this 1. So we have the restriction 4 over 3. So it will be the barrier of our solution. Okay? So from 4 over 3 until negative infinity, union to 4 over 3 until positive infinity. So that will be your domain. So let us now solve for the range. Okay? So I will get this one, or I will just solve it here. So computing for the range, we have y is equal to 2x plus 1, 3x minus 4. Just putting your h of x into y form. Then isolate. So let us cross multiply. So we have y cross multiplying 3x minus 4. So cross multiply. Okay? Equals, copy the numerator, 2x plus 1. Then, distribution property, we have 3xy. Multiply, we have negative 4y equals to, copy, 2x plus 1. Okay, combine like terms, or combine all the terms with x. So minus 2 will be transferred, it will become negative 2x. Then minus 4y will transfer, it will become 4y, copy, plus 1. Then, what is the common between this 3xy and minus 2x? So the common is x, of course. So the remaining term will be 3y minus 2. Copying 4y plus 1. Okay, so are we clear in this? Then, cross multiplying, or if you can imagine, we are just cross multiplying, just like we did with this one, cross multiply. Below, up, below. Or, you will get on this form. X. Or if you have the concept, we have 3y minus 2 equals to 4y plus 1. You have divided y minus 2. Y minus 2. So therefore, x is equal to 4y plus 1 over y minus 2. Minus 2. Okay? Sorry, we have 3y. So that is what's happening. But if we can, if you want to make it simple and short, just bring it down below 4y plus 1. Okay? If you can see, our denominator is 3y. We have 3y minus 2. Okay? So now we will be solving for your range. Range. Solving your range, just identify the denominator after you simplify your h into x form. So we have your denominator 3y minus 2, equate it to 0. Then minus 2 will be transferred, so we will have positive 2 equals to 3y. Then y is equal to 2/3. Just like cross multiplication. So we have, example here, we have minus 2. We transferred it on the other side of your equal symbol. Your minus 2 will become plus 2. Okay? So we are using the inverse of the equation. Here, 3 times y. 3 times y. So we are multiplying 3. If you transferred it to another side of your equal symbol, then we have times 3 in here, we have divide 3 in here. So just doing the inverse. So the range is y not equal to 2/3. Set builder notation, we have y is an element of real number such that y is not equal to 2/3. Using your interval notation, we have this notation. So 2/3 will serve as the barrier, the solution, until negative infinity, until positive infinity. Okay? So that is just solving for the domain and range of h and x. So let us now go to the domain of the inverse of h. The domain of the inverse of h. So look at the denominator. We have 3x minus 2. So equate it to 0. So minus 2 inverse is plus 2. Then we have 3x. So the inverse of 3 times x is divided by 3. Or divide both sides by 3. So we have x equals to 2/3. But the domain is x is not equal to 2/3. Okay? Then by using your set builder notation, so we have x an element of real number such that x is not equal to 2/3. Okay? Then by using your set builder notation and interval notation, we have 2/3, 2/3, until negative infinity, until positive infinity. Okay? Okay, so now let's go to solving the range. So before solving the range, let us solve this one. Your h inverse of x into y form. So we have y is equal to 4x plus 1 over 3x minus 2. Okay? So I guess this. Then, cross multiply, we have y times 3x minus 2 equals to 4x plus 1. Then we have, just copy 4x plus 1 in here. Multiply y times 3x. So we have 3x y minus 2y. There. Then combine the terms with all the x. So we have 3xy minus 4x. Then we have positive 2y plus 1. So minus 2y. And minus 4x. Okay? Getting the common factor between 3xy and 4x. So we have the common of x. So we have 3y and minus 4, copying 2y plus 1. Then, cross multiply or divide both sides by 3y minus 4, we get x equal to, your numerator is 2y plus 1 and your denominator is 3y minus 4. So just look at your denominator. So your denominator is 3y minus 4. So solving the range, is 3y minus 4 equals to 0. Solve for y, minus 4 will become plus 4. On the other side, equals to 3y. Divide both sides by 3. We will get y equal to 4 over 3. Then your range is y not equal to 4 over 3. There. And using your set builder notation again, y is an element of real numbers such that y is not equal to 4 over 3. And using your interval notation, we have this one. 4 over 3 as the barrier of your solution, or the value of y, or range, then until positive infinity, until negative infinity. So if you can see, comparing the domain range of the function and its inverse, you can see it, the domain of h is the range of the inverse of its function. You can see. Okay? So again, the domain and range of a function and its inverse is interchanging or interchange. Okay, so I guess that you have learned something in this video. Please subscribe and stay safe.